All right, so I need to talk to you about trigonometric ratios. So we're going to start trigonometry for this lesson. So there are three main words that you need to know in trigonometry, and these three words will represent the different comparisons between different sides of a right triangle. So we've got in every triangle a right angle, and then we've got two other angles that are not the right angle. So in trigonometry, we are actually going to be focusing on one of the other two angles that is not the right angle. And then, of course, we've got two legs in a right triangle, and we have the hypotenuse of the right triangle. Remember, the hypotenuse is always opposite the right angle. So in finding the ratios of the different functions of trigonometry, there is a function called sine, a function called cosine, and a function called tangent. By the way, this chart is on page 506 of your book if you want to look at it in your book. So finding the sine, cosine, and tangent is just going to involve using your calculator, which I'll show you how to do in a second, but it's also going to involve setting up the appropriate ratio. So that's the first thing we're going to do. So if I want to find the sine of angle A, then what I need to do is I need to locate angle A, and then I'm going to plug in values from different parts of the triangle based on what I always will do for sine. So sine is always the length of the leg opposite angle A over the length of the hypotenuse. So here is angle A. The side opposite angle A is side A, and it's not uncommon for the sides to be labeled with a lowercase letter that's the lowercase version of the capital letter that you use to name the angle. So opposite over hypotenuse would be A over B. So that's the sine of angle A. The cosine would be the leg adjacent to the angle over the length of the hypotenuse. So here's angle A. This blue line is adjacent. How do you know it's adjacent? Because it's the leg that actually touches the angle. So adjacent B over hypotenuse C. So the cosine of angle A would be B over C. The tangent of A would be the leg opposite over the leg adjacent. Now, remembering how to do all of this, remembering what all of these trig functions go with, is going to be kind of difficult. So we've come up with a few devices here to help you remember. You can use whichever one you want. A lot of teachers teach the phrase SOHCAHTOA. SOHCAHTOA. And SOHCAHTOA, the letters tell you how to set it up. So that would be sine is equal to opposite over hypotenuse. Ka would be cosine is equal to adjacent over hypotenuse. And toa, tangent, is equal to opposite over adjacent. A lot of people use that to remember these formulas. These formulas are very important. You're going to need to know that. So, and I should have written out the abbreviations for these. Sometimes you'll hear me refer to them by their abbreviations. SIN is not sin in trigonometry, it's sine. So SIN really is an abbreviation for the word sine. COS is the abbreviation for the word cosine, and TAN is an abbreviation for the word tangent. So SOHCAHTOA is one way. Another way is the phrase, some old hippie caught another hippie tripping on acid. Some old hippie caught another hippie tripping on acid. So you can use either one of those. Whatever helps you remember this setup right here is what I want you guys to be able to do. Now remember, this is the setup, but in reality, the trig functions will all be assigned to an angle. So if I wanted to go back through and look at the sine and the cosine and the tangent of each of these things, I could say, let's say I want to look at angle B. So the sine of angle B is going to equal the opposite side to angle B over the hypotenuse. So if we look at angle B, which side is opposite angle B? Well, it's little b. Which side is the hypotenuse? C. If I wanted to do the cosine, if I wanted to do the cosine of angle B, that would be, so here's angle B, the cosine is the adjacent over the hypotenuse. So that would just be A over C, because side A is adjacent to angle B. And if I wanted to do the tangent of angle B, that's going to be, the tangent is the opposite over the adjacent. So in this case, the opposite of angle B would be side B, and the adjacent to angle B would be side A. So here are the trigonometric ratios when I'm looking at angle B. Here are the trigonometric ratios when I'm looking at angle A. You can't do trigonometric ratios for angle C because angle C is the right angle, and we never focus on the right angle when we're looking at trig functions. You'll do that later in another course. All right, so let's do this problem. What are the sine, cosine, and tangent ratios for angle T? Very simply, all I'm asking you to do is to do sine, angle T, cosine, angle T, and tangent, angle T. I'm just asking you to find those ratios. Later on, I'll show you how to convert those ratios into a degree. All right, so what are the sine, cosine, and tangent ratios for angle T? Well, remember, sine is represented by opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. All right, so in this particular problem right here, the opposite to angle T, here's angle T, its opposite is 8, and its hypotenuse is 17. And for right now, we won't reduce these. I just want to get you guys in the habit of setting up the ratios. That one doesn't reduce anyway, but if one did reduce, we're not going to reduce it. So the cosine of angle T is adjacent over hypotenuse. So here's angle T. The adjacent is the side that touches it. It's not the hypotenuse, so that's 15 over 17. And then the tangent is the opposite over the adjacent. So the opposite is 8, and the adjacent is 15. So you got to pay attention to what angle you're looking for so you know which correct side to pick. How did I remember all of this stuff? Well, SOHCAHTOA, sine opposite hypotenuse. So CA is cosine is adjacent over hypotenuse. TOA, tangent, is equal to the opposite over the adjacent. Oops, that should be an A. Or some old hippie caught another hippie tripping on acid. Okay? So what I want you to do now is I want you to do this problem. I want you to use this triangle right here, and I want you to find the sine, cosine, and tangent for angle G. All right, so hopefully you were able to find the sine, cosine, and tangent for angle G. The sine for angle G was equal to the opposite over the hypotenuse, which in this case is going to be 15 over 17. The sine of angle G, the cosine of angle G is equal to the adjacent over the hypotenuse, which is adjacent to G would be 8, opposite or hypotenuse would be 17, and then the tangent of angle G would equal the opposite over the adjacent, which in this case the opposite is 15 and the adjacent is 8. So that's all there is to setting up the ratio. So we're going to use a trigonometric ratio to find the distance. So in 1990, the Leaning Tower of Pisa was closed to the public due to safety issues. The tower reopened in 2001 after a 10-year project to reduce the tilt from vertical. So the engineers' efforts were successful, and as a result, a tilt of 5 degrees reduced from 5.5 degrees. Suppose someone drops an object from the tower at the height of 150 feet. How far from the base of the tower will the object land? Round your answer to the nearest foot. And we're going to use the fact that it was 5 degrees in the tilt. We're going to use the 5 degrees, the reduced. All right, so let's think about it. So we've got 5-degree angle right here, and then we've got our distance from the base of the tower to where the object would land, and then we got the 150 feet distance that is dropped. So if you look at it, it makes a right triangle that looks like this. Okay, and we know that that's 5 degrees, and we know that that is a right angle, and we know that this is 150 feet. And we're looking for the value of x. So interestingly enough, we've got this right triangle with a degree measure and a distance, and we're just missing this value. Now, if this were a special right triangle, it would be easy to crank that out based on what we've learned previously, but it's not. So now is where we use trigonometry. So the first thing I'm going to do is I'm going to analyze the sides that I'm working with. In this right triangle, in relationship to the 5-degree angle, 150 feet is adjacent to the 5-degree angle, and x is opposite the 5-degree angle. So I am working with the adjacent, and I'm working with the opposite. If we go back to our formulas, which one of these trig functions deals with opposite and adjacent? And hopefully you discovered that the one that deals with opposite and adjacent is tangent. So tangent is the one that I'm going to use to solve this problem. And so if I were to set it up, the tangent of a 5-degree angle is equal to the opposite, which is x, over the adjacent, which is 150. So you see how 150 is adjacent to 5, and you see how x is opposite 5, and you see how the angle actually had a degree measure of 5 degrees. So now we can actually find the value of x. Here's how we're going to do that. First of all, we need to solve for x. If I want to undo dividing by 150, I use multiplication. So 150 times tangent 5 degrees will be equal to my value of x. All right, so at this stage we're going to have to use the calculator. So let's talk a little bit about the calculator. So when we're working on trigonometry, our calculator needs to be in a certain mode. In this course, we are always going to use degrees. So our mode needs to be degrees. So I'm going to turn the calculator on. I'll clear it out. I'll hit mode. And so at the top, you'll notice that it's deg, rad, grad. Make sure your calculator is in deg mode. Now, the way that you'll know it's in the correct mode is if you take the tangent. So there are buttons on here, sine, cosine, and tangent. If you take the tangent of a 45-degree angle, you should always get 1 as an answer if it's in degree mode. If I change the mode to something different, like radians, and then I try to take the tangent of a 45-degree angle, I do not get 1. So what I want you to do is when you start out, before you start doing any trig problems on homework or a test or anything like that, the first thing I want you to do is I want you to take the tangent of a 45-degree angle. And if you don't get 1 as your answer, if your answer isn't 1, then I want you to check your calculator settings and fix that. All right. Back in this problem, we had 150 tan 5 degrees. So that's what I'm going to put into my calculator. Okay, I'm going to put 150 tan 5 degrees. Now, some calculators work differently. Some calculators, if you're not using the ones that group things with parentheses, sometimes you have to enter the degree first and then hit the trig button, and it'll give you a number, and then you can multiply that number by 150. That's why I like these particular scientific calculators right here, because they remember order of operations. You can just enter stuff in. So 150 tan 5, I'm going to hit enter, and that's 13.123. So when I go back to my problem, round to the nearest foot, so this was 13.1 something. So rounded to the nearest foot, it was 13 feet. And so that's your solution. So if I was 150 feet up on a 5 degree angle and I dropped a ball, I'd be 13 feet away from the base, or approximately. So now what I want you to do is I want you to go through and see if you can't find W to the nearest tenth using the different trig ratios that you would need to use. So first of all, let's talk about what trig ratios you'd use. In this one, you've got a 54 degree angle, so you can use 54 degrees, and opposite and hypotenuse would be a sine function. In this one, you've got 28 degrees, and opposite and adjacent would be a tangent function. And in this one, you've got 33 degrees, and hypotenuse and adjacent, that would be a cosine function. So go through and see if you can't work these, set these problems up, and see if you can't solve for the missing variable in each of these problems. All right, hopefully you were able to come up with these solutions. Here's what we've got. For this one, I already told you that since this is the angle right here, and we have the hypotenuse, and we have the opposite, this is going to be a sine function problem. So how do I know it was sine? Because the two sides I was dealing with were the opposite, W, and the hypotenuse, 17. Now how do I solve for W? Well, I'm going to multiply both sides by 17. So that's 17 times the sine of 54 degrees is equal to W. And then I'm going to go put this in my calculator. So I go back to my calculator, and in my calculator, it's 54 degrees. I forgot what the number was. It was 17 times 54 degrees. So 17 sine 54. Hit enter. So I get 13.75. If I'm rounding off to the nearest tenth, 13.75 is approximately 13.8. Right, over here, the setup is going to involve cosine, because we've got the adjacent side, and it's going to involve tangent, because we've got the adjacent side and we've got the opposite side. So tangent, 28 degrees, and that's going to equal opposite 1 over adjacent W. Now this problem's a little bit tricky, and the reason it's tricky is because here we have the variable in the denominator. So I can't just multiply both sides or divide both sides by 1.0, because it leaves the number in the denominator. When you get in this situation, what I want you to do is I want you to treat both sides like a fraction and then just cross multiply. So W times tangent 28 degrees will equal 1. And then isolate W by dividing both sides by what's not W. Tan 28 degrees, tan 28 degrees. So here the tans will cancel out, and W will equal 1 over tan 28 degrees. So when you go back to your calculator, we're going to divide 1 by tangent 28. And so that'll be 1.88. We're rounding off to the nearest tenth, so that'll be 1.9. So W is approximately equal to 1.9. Over here, the setup is going to be cosine. So cosine 33 degrees is equal to the adjacent W over the hypotenuse, 4.5. So when I solve for W, it's 4.5 times cosine 33 degrees equals W. And so W will approximately be equal to whatever 4.5 times cosine 33 is. Once again, I go back to the calculator, 4.5 cosine 33. And I get 3.77, which will round off to 3.78. So that's how you use angles and one side to find the other measures of the sides of a triangle. Now, what happens if you have two sides and you want to find the missing angle? So you can use something called the inverse function. So an inverse is just something that undoes something. So if I had 3x equal 9, I would solve that by dividing both sides by 3. Division is the inverse of multiplication, and I get x is equal to 3. If I have something like x squared equals 16, the square root undoes squaring, and so x is just equal to 4, plus 4 minus 4, but in the case of geometry, usually it's 4. All right, so I want to use the same concept. So what I'm going to do is I'm going to create my problem, setting it up just like I normally would. So I want to find the measure of angle x. So here's angle x right here. In relationship to these other two sides, x, looking at 6, 6 is opposite. Looking at 10, 10 is the hypotenuse. So which trig function involves the opposite over the hypotenuse? Think about that for a second. All right, hopefully you thought that, oh yeah, it's sine of angle x. I'm just going to put x instead of angle x. Sine of x is equal to the opposite over the hypotenuse. All right, now how do I solve for the angle? Well, we use these things called inverse trig functions. And an inverse trig function is basically just writing the trig name and putting a little -1 exponent to it. So sine inverse, and we do that to both sides of the equation. So what I'll do is I'll just rewrite this a little bit further over, because what I'm going to do is I'm going to take the sine inverse of both sides of the equation. Maybe I should have written it a little bit better. Maybe I should have done this so that you can see what's going on here. So now what I'll do is I'll take the inverse of both sides. So I'm going to take the sine inverse of both sides. Why am I using the sine inverse? Because I had started out with sine. So to undo sine, I need to use sine inverse. So the sine inverse of sine x will equal the sine inverse of 6 over 10. So sine inverse is what undoes sine, and that's what just leaves me with x. And this I do on my calculator. So how do you do sine inverse of 6 over 10 on your calculator? Well, we'll go to our calculator, and I'll clear everything out so you can see the screen. So now, when I'm punching the buttons, instead of just hitting the sine button, I'm going to hit second function sine. And notice on the display it's sine inverse, sine to the -1. And then 6 divided by 10. And so that's 36.86. If I'm rounding off to the nearest degree, which I think I'm supposed to, rounding off to the nearest degree, 36 rounded off to the nearest degree is 37. So I can find that that's 37 degrees. So how do you know you can use sine, cosine, or tangent to find an angle? You do that anytime you're looking for the angle, you'll use the inverse function. Okay? You'll use the inverse function. And so I had the setup with sine x is equal to 6 over 10. I know I'm looking for the angle, so that's what tells me I need to take the inverse of both sides, and then my answer is going to be in degrees. So what I want you to do is I want you to use this figure right here, and I want you to find the measure of angle y. And you're going to have to figure out which trig function to use, and then you're going to have to use a sine inverse. All right, so hopefully you were able to set it up as a tangent function. Tangent y is equal to, tangent is opposite over adjacent, that's why I'm using tangent. So I had the opposite, 100. I had the adjacent, 41. Now, to solve for y, I need to take the inverse tangent of both sides. So tangent inverse, and then is equal to tangent inverse on this other side. And so the tangent inverse of tangent y is going to equal the tangent inverse of 100 over 41. Remember, this is just like Algebra 1. You can do anything you want to a side of an equation, just as long as you do the same thing on both sides. So tangent inverse and tangent are going to cancel out and leave me with y. Tangent inverse of 100 over 41 is something I'm going to do on my calculator. So I'm going to do second function tangent to get the tangent inverse. 100 divided by 41, and I hit enter. And I get 67.7, and so I need to round that off to the nearest degree. It didn't tell you to, but I'm going to tell you to. Round it off to the nearest degree, so that would be 68 degrees. Usually degrees will round off to the nearest degree, and side lengths will round off to the nearest tenth, but unless I tell you otherwise. All right, so that's all there is to it. You're going to be setting up trig equations, and you're going to be solving for the missing variable. Go back through this video and review any of the concepts that you missed, and tomorrow in class we'll start on the homework. See you then.